All right, so as he said, my name is Chris White. I'm the WSC DevOps coordinator at Livermore. And I wanted to, so last year, I noticed there was a lot of here are all the pain points of Spack and why my life is miserable. So I wanted to take a little step different, a little flavor of that, and kind of showcase where the pain points are, but what are the great collaborations that came out of that and the great tools that help the entire community. So, and then I also have my team on there, but work at Livermore. All right, so topics. Spack 1.0 transition. This year we spent a lot of time moving people off of either their bespoke solutions or their old Spacks onto a new, somewhere in the after 1.0, most of them are 1.1 at least, and there was a lot of pain points on there, and so the really high level goal that we're trying to do is get everyone onto a shared Spack solution, and that makes kind of sense for our very multi-team effort. So what are we? I'll go very quickly over this. WSC, the computational physics program, we have lots of simulation codes. We have about 120 developers. This is kind of an old slide. I don't know if that's accurate anymore. Roughly about 15 teams. A lot of these codes live for 30 plus years. Millions and millions of lines of code, diversity in languages, C, Fortran, Python, Lua, many-core, multi-memories. I'm sure I don't have to tell you guys all this. It's hard. What a physics code looks like. We have CS infrastructure, physics libraries, numerical methods, and then we have the CS stuff at the bottom, problem setup, visualization. So very complex, lots of libraries, and this is kind of what a library looks like, or a code looks like. So our physics codes can have somewhere of 80 plus 100 libraries. So that's pretty much of a nightmare to deal with. And each TPL has its own build system configurations. I'm preaching to the choir. That's why Spack exists. And so we want to manage that. But something that's very key to our life is that determinism is essential. And it's something that we struggle with in everything that we do. And so we need to lock down as much as possible, whether it's compiler packages, even flags, compiler flags have to be locked down, because when these change, at worst, your answer is slightly wrong. And when you're dealing with important physics simulations, that isn't horrible. So if I change an answer, I'm not a physicist. I don't know what the code is really doing. So I have to go get someone, and they don't want to do that. At best, it might fail quickly in the build. And so this is an eternal struggle that we have to fight, but we do it anyways. So onto the Spack 1.0 thing. So we, in Spack 1.0, compilers as nodes came in, and it was, it is here to help better model compilers. And, before on the left, we did this by line. We had a compiler spec, and we said it was Clang, but really it was Clang and G-Fortran. But it did work. We all did it. But this way, it moved on to the right where we have, GCC and LLVM, and then we, mixed them together. But what happened is that was a little painful. So this led to two complications: extremely long specs that users had to type on the command line. So before it was, Axum at some version with some compiler, and that turned into the second line, which is, no user of mine is going to type that. And also the second one is that the concretizer often defaulted to alternating between compilers. And this hit every single user that we had. They got very angry. At best, it failed. At worst, it just did really weird things. So you can see in the second one, Axum's building with GCC, then it flipped to LLVM, then it went back to GCC. We never wanted that. So I was talking to Greg one day. I was like, look, this is one, I don't want to type that every time. They'll kill me. So can we do a spec alias or something? And Greg took that and came up with a much better solution, which is toolchains. And this actually solved two of our problems. Not only do the users not have to type that horrible string. They can just say clang 19, but it actually allowed us to lock in the compiler-specific MPI, and this is something that has been plaguing us for probably 10 years. It would just silently swap to the Intel MVAPage, and I'm sure Greg was tired of me telling me that it swapped the MPI again. So this allowed us to lock it in. So to fix the second complaint, the compiler flipping, we needed to be able to disable compiler mixing because I would never ever want that as in our use case. And so Max came up with a way of doing this on the command line. So, you're all familiar with the first line, Axum, %clang, that's a node local requirement. They came in with the preference down the tree, so you could say %clang. That's still a preference though. We want it really, really required, and so this is the third line, %, is coming. I challenged them to come up with 4. I'm not entirely sure why it's not just %. I'm going to be honest. It is a little sad, but it's also kind of funny. So, so the second one, which is what I really use, thank you, Peter, is an option in your concretizer to just say never compiler mix. And so this is actually what we use. I don't know anyone that uses the middle one, but it's there. All right. So coming on to the last one, I think we often have multiple Spacks building. I support multiple teams. Every team will not decide and agree on a Spack, so they all act differently, and they're all writing to your home directory, which is not great, but it is what it is. So they put in the Spack disable local config. This helps, but I'm going to be real. It doesn't catch every use case. This was especially painful in the Spack 1.0 migration because if you had one team pre-Spack 1.0 and one team after Spack 1.0, it was injecting language things into your directory, and it would fail at Spack bootstrap for extremely confusing error messages that no one would understand. And ultimately, we want each Spack instance to be isolated. So thank you, Todd. We now have a better way of ordering and removing config scopes. You can now edit your etc, Spack include and override the environment and just have exactly one. But I'm a lazy person. I don't want to do that. So they're eventually going to create a command called Spack isolate, where you just say, you clone Spack, you say Spack isolate to this directory, and everything that it writes will be in that directory. Todd promises me this is going to be done. No pressure, Todd. Who doesn't want isolation? No one has actually been against this. It just needs to get done. But I mean, by default. Why? There's lots of arguments for that. Site, Spacks, but we'll talk about this afterwards. Everyone wants this, in my opinion. And they're wrong if they don't. Okay, so the concretizer has been a wild ride. I'm going to be honest, guys. Concretizer temporarily got significantly worse. If you are not on a very newer Spack, please move forward. Spack 1.1 had multiple speeds. One of the teams that I work with went from about 1 to 2 minutes of concretizing all the way up to 30 minutes per concretizing, and that was a successful concretization, down to 2 to 3, which is still, twice as much as it was before. Thank you, Max and Harmon, for those fixes. Sometimes concretizations can be skipped entirely now. Thank you, Greg. So if you're doing like a Spack develop with no modified concrete specs in 1.1, but in 1.2, Spack change concrete will sometimes not concretize, which is great. Errors out of the concretizer have greatly improved. I can almost read them now. So I just gave up before. I personally liked the time it just said error : that was good. That was better than the first one, which was error debug, when I didn't have a debug variant. You're just better than me, Todd. I'm just saying, okay? All right, so back to, this is kind of like, from now on, it's the update from last year's. Last year, I talked about how we're going to be unifying everyone's thing. I expected to be done by now. Clearly, we're not. But here's a kind of high-level overview. There needs to be a better improved communication of build configurations between projects. We have integrated codes that are building a million different libraries. If something breaks, an Axum, which is one of their libraries, they need to be able to communicate what their spec is. And so you have my contractually obligated AI image that, I want the whole pie, not just a picture. So they'll come to me and say something like, Axum is broken with Clang. And it's like, no, it's not. But what I want is the entire spec to figure out exactly what they're doing. And even that's trench gated. So we have a config relay. Part of this, though, which is slightly out of order, but we created a config relay. It's passing on all that information now. And another problem is we have a plethora of package repositories. And it's kind of a nightmare, the different configurations everyone has. Not only are they having different recipes, points in history, patches, fixes, they don't talk to each other. So this is where we started at last year. And this is obviously just trench gated. But we are, and you're ready for it, like that now. Thank you. This is a crowning achievement for me. We're sharing recipes, patches and fixes, environments. We're still, and I don't think we're ever going to solve this. We're all at different points in history. We have different specs, different recipes, and we want to allow that. I can't go to every team and be like, you will update your spec today because another team did. So again, we still have a goal, and we're much farther about this, of having all the upstream projects contest against the pre-built correct integrations. So you have these downstream projects, the integrated codes, whether it's a library or whatever. We want this configuration relay to pass their build information. 5 minutes. I'm getting farther than I thought. I thought I'd run out of time already. Sharing this with the TPL build farm. There's actually 2 of those. And then it deploys these pre-built library sets. So codes that are in either whether it's GitHub or the CZ, the RZ, they can test against these exact builds from the integrated codes, because that's really why we're here, is to make the integrated codes work. This isn't really important. I mean, it is important, but no one cares here. Our approach is safe and secure. I don't want to scare any managers. We're not just willy-nilly throwing information around. So here's what we created. This is the whole picture. We have the integrated codes down the bottom left. We have a config relay that had its first successful config relay like last week, which is awesome. And it sends all of that information to the package repo build farm. It then deploys a build cache and some library sets that can be reused either by the integrated codes or libraries that are on the RZ. It then relays the information to the CZ. That's not quite working yet. We haven't mocked up. Again, it worked last week, so. And then the idea is that it will config relay the relevant information to the CZ, rebuild them again, and then Axum, Raja, Umpire, they don't have to build their libraries anymore. They will have exact sets, one for AL3D, Marble, Cole, whatever. And this is all automated, fancy. It's pretty great. So, just a heads up, we heavily leverage Spack CI. It's pretty great. In a very small amount of lines of CI, we generate and build all sorts of things. It knows what libraries need to build again, what need to be deployed back into the build cache. We have several fancy new features thanks to Alec this year. Like if someone pushes up a change into a merge request, it builds into a merge request specific build cache. And so once it's approved by a very small amount of people, it then is rebuilt into the main build cache, so you don't pollute your build cache, which we definitely did do. So that's my talk. It was pretty great. Yeah. So I was shocked how quickly I polluted my build cache. I was like, I'm going to do this, and I did it. So Alex saved the day. All right. Any questions? Clearly it was, I was going to say it was so perfect, no one had questions.
Just I guess a question, maybe a comment too. Like, so if you're going to require no compiler mixing all the way down the stack, and then you do want visibility all the way down the stack, just as a heads up, some of the dependency packages for things like MPI, once you get to like the system packages layer, have to depend on GCC, and especially like the one that came with the system, as there's to get like accurately represented externals. And for an example of a package like xpmem, since it's a kernel module, it's actually going to like the way it's in Spack, that it requires that it be GCC. So you might actually prefer, or you just maybe don't want to see that level.
We cut it off at externals.
Okay,
we do not build MPI. I mean, sometimes we do, but we have system deployed MPIs that are compiler specific.
You can also set an exception for certain packages from the compiler mixing restriction.
In this context, what exactly do you mean by a config relay?
I don't have it in this talk. This is horrible. Okay, so basically, an integrated code concretizes. At that point, the config relay allow lists a certain level of packages, and it grabs that information plus the environment, and it relays it to the shared area, because that's the stuff that can be shared, and we then rebuild it there. So we're also going to try to get that in Spack as maybe like Spack EMV reduce, so you have a concretized environment and you can share it with other people.
This is like, so when we first started doing this and trying to support these guys, we had them put relevant packages that depend on in the CI, and that helped a lot, but they weren't testing the exact configurations that they code to. And so what this does is it gives you the variants and all of their information that they're using, so we're testing exactly what they're doing.
Yeah, for an example of this was we lost actually 2 weeks of effort trying to track down that one of our customers had a variant on umpire that was not in the main recipe, and we had no idea it existed. So that was very frustrating. So this will solve that problem.
All right, I think we have time for one more question. Patrick, can you come up and get ready while we...
This one is out of curiosity, so I'm here. You mentioned not mixing compilers. Is there a specific reason why?
Yeah, most of the time it won't even build if you swap back and forth between Fortrans. And sometimes it will change your answers. So when you're doing physics simulations and like you have 64-bit floats that are doing a bunch of horrible math that I don't understand, it will change your answers drastically. So we want to lock it down completely. And also, you know, if you're testing things to make sure your library works with GCC, I don't want Spack deciding to build with Clang.
Part of the issue there is that we don't fully model the LLVM runtime libraries the way we do for the OneAPI and the GCC libraries yet. And that's simply something where we have to go in and figure out which files match to the runtime libraries for Fortran. And once we do that, it would prevent most of the cases that won't build, but it still wouldn't prevent the cases that Chris is talking about where you would get incorrect answers.